So Tesla's question, which then gave birth to his circuit, was:
you provided a list of components used in your system.
I think in the year 2025, there's a very anomalous thing that I've also been observing. That is,
could you please describe step by step how to replicate your installation at home for our viewers?
And if that is to be done, an interesting result then happens.
What is the key to extracting energy from the surrounding environment?
It simply means people have been to more or less an unlimited potential of generating an unlimited amount of energy.
Sounds very fascinating to have access to this unlimited energy. Greetings, dear guests. Today's hosts are Sergey from Dubai.
Hello.
And me, Ksenia from Amsterdam. And we have a special guest, Tapiwa from Zimbabwe.
Hi everyone, how are you doing? I hope you're all good.
Good afternoon, Tapiwa. We are very happy to welcome you back as our guest. In the previous interview, you presented the design of your energy generator device and demonstrated its operation. And this sparked guest interest and many questions from the viewers, other engineers, and enthusiasts. Today, we would like to dive deeper into your systems. You mentioned that your installation is based on Tesla's and Bedini's systems and shared a detailed description of them. So the first question would be, could you please explain to our viewers in simple terms how the Tesla 4 battery circuit works?
All right, I sure will do that. So I think the man himself, Nikola Tesla, he was a very much exceptional inventor, in my opinion. And I think on the list of the things that he managed to come up with, one very interesting yet not so talked about innovation of his was the 4 battery switch. So the whole philosophy behind it, if I can say, is it was more about realizing other anomalous behaviors that cells or batteries can sort of exhibit. And it was more or less what we would call a strange phenomenon in science, whereby something behaves in a certain way that can be, adequately explained with the frameworks that will be there. So his sort of standpoint was, if, let's say, for example, we have got a battery which moves electrons from its cathode to its anode, essentially, if we start with a battery with 10 electrons, even if it is to deplete, it still has 10 electrons because they just moved from the cathode to the anode. And in essence, it still is what it is. So when we now say a battery has lost energy, according to Tesla, that wasn't like giving the full view of what would be actually happening. Because according to him, what would have only happened would be sort of establishment of an equilibrium within the cell, whereby there's an even number now of electrons on one, let's say, electrode and the other. So what gives a cell its energy, if we are to say it that way, is simply the reason that, there are more electrons on one electrode, which are then transferred to the other. So in essence, batteries don't really lose energy as we say it. They simply end a state of equilibrium whereby those electrons are not able to flow. So Tesla's question, which then gave birth to his circuit, was, what if we could ensure that as one battery sort of powers a circuit, the electrons move from its, let's say, negative to the negative of another battery through the load. And at the same time, the positive of that battery is connected to the positive of this battery as well. And if that is to be done, an interesting result then happens, whereby you have got one cell that is effectively doing work, and the other that is sort of charging and rejuvenating from which is doing work. Meaning, at the end of the day, we can more or less say the energy hasn't been lost. Simply, when this one has entered in equilibrium, the other battery or cell was establishing its own disequilibrium. And hence, if you are losing voltage here, it's being gained on the other side. And then what you have is now a system whereby you can oscillate voltage from one battery to the other, and it can just go on and on and on like that. So that's what the Tesla 4 battery switch was. It then modified it so that it would work with a total of 4 batteries. So you'd have battery 1 and battery 2 that are connected in, let's say, a series that is negative, positive, then the positive to the negative of the other. Then they become, a set of, or a pair rather, of 2 cells. And then these were then used alongside another pair that was used sort of like connected in parallel. And hence, the effect then would work effectively. Why? Because it would allow at least this pair to move its electrons, since it is sort of like a higher, in fact, since it has a higher voltage due to series connection, to the other, of course, which has got like the minimal voltage difference. So in this was what was going on. So in short, that's what the Tesla full battery switch is. It's simply a utilization of phenomena of cell behavior so that we are able to effectively realize energy gains beyond what we would normally do in day-to-day life.
Thank you, Tapiwa. Yeah, we want to dedicate today's video totally to the technical details of your innovation. We understood current in wires is the movement of light and fast negatively charged electrons, the movement of heavy and slow positive and negative ions. And ions are formed through electrolyte dissociation, for example, sulfuric acid. At the moment of switching batteries, the current in the wires almost instantly changes direction. Since electrons are light and fast, they accumulate at the input terminal of the battery, creating a kind of traffic jam. This is why charging begins with the strong current pulse at the battery input. And could you please explain in more detail what happens at that moment and why this effect is important for the operation of the whole system?
All right. So yeah, that very much is the case. At the moment of like initial, let's say, entry of the electrons from the terminal of a particular battery to the other, they're more or less hit what we would call maybe a traffic jam in their index. The whole essence of that was to seek to explain, let's say, the strange behavior that was happening. Because when the experiments were done, that is by the guys who initiated this, the likes of Nikola, Tesla, and John Bedini, it didn't make adequate sense how a simple cell that has just simple redox reactions that are happening at a chemical level be able to sort of rejuvenate itself, or in a way undergo what we would call reverse entropy, that is being able to recharge itself. Because when a cell works, basically it's discharging, and it being able to recover means it's sort of establishing its own disequilibrium, which is something that is rather strange. So to be able to be sort of like logical about it and to effectively explain it, they wanted to sort of factor in, I think, the idea of how this cell could actually be able to tap into the quantum field itself, because that would seem like the most likely, source of this extra energy, where it would be potentially coming from. So I think one basic fact that everybody in the science world agrees to is, in as much as you have atomic particles, they are subatomic particles, and if you got that, you get to discover other levels. But in the field of, let's say, quantum physics, the general proposed theory is that of, the string theory, whereby they say, let's say, each and every existent subatomic particle, elementary particle, it's more or less an effect that is produced by a vibrating stream of energy that is more or less rooted in the quantum field itself. It simply means even if you're observing an electron, or maybe a proton, or maybe a neutron, in essence, those are just visual effects of vibration of these strings of energy at different frequencies. It then occurred to these guys, they then had this epiphany, whereby they asked themselves, what if at that moment whereby these electrons are clustering, they're actually able to sort of alter the quantum field around them, such that they sort of are then able to tap into more energy, and that energy allows them to effectively do more work, that is, be able to reorganize themselves without the need of an external charging mechanism. And then that's the whole proposal then, which was put forth, that most likely when this circuit is working, you've got clusters of electrons that are occurring at a particular charging pulse. So when it occurs and it basically sort of alters the quantum field around it, it then gets to tap into extra energy, which then allows it to undergo what we can term, reverse entropy in a way. And that way, it sort of is able to establish that, let's say, polarity, which is naturally there in a cell, whereby you've got the negative and positive, simply because the negative more electrons than the positive. So it's very essential in the functional setup of this kind of circuit itself, because with that window, or that, let's say, opportunity, whereby these electrons can tap into this extra energy, effectively, it wouldn't be possible then for it to be able to establish the disequilibrium and recharge itself, because there wouldn't be any other sort of rational way to explain how the cell is able to do that, because it just cannot be it in, considering how things work within chemistry itself and the general field of electrochemistry, which means there is need for that explanation to be able to sufficiently account for how the cell is able to behave in an awkward way. So more or less, it will be a quantum field effect that is having recognizable gains in the physical field, of course, that we can effectively see and interact with. And that can only happen through electrons themselves, which of course we can see. And at the same time, they are rooted in the quantum field itself. So they act as sort of like the bridge between the effect of establishing reverse entropy, and essentially the energy reserve that is existing within the quantum field itself. So they are more or less like, what can I say? They are the cornerstone of the whole functionality, because without them, I don't think there is any way you could possibly explain how they can get to happen. So I think that's why it's a very vital, let's say occurrence within the function of the cells themselves.
Thank you. And is it also correct that if the battery is discharged to a low level and then the circuit was switched on with the load, the recharging of the batteries occurred in less than 1 minute? And moreover, the more discharged the battery, the faster it charges. And during such a rapid changing, no heating is observed. Do you have a physical explanation to what caused the discharged battery to recover its charge so quickly, and what role does the external environment play in this process? And the last question, does such charging speed damage the battery, since normally this process takes much longer?
So I think before I answer the question, I think it would be quite fair if I give a reference to what we normally do with, let's say, car batteries. So sometimes as a person, you may encounter a scenario whereby you've got a flat battery. So when you have a flat battery, it means it doesn't have the effective potential difference that is required to, let's say, drive the system. So what you do is you take another battery with, a higher potential difference, and basically you connect this battery to the other battery, negative to negative and positive to positive. And, that's what we call jump starting a car, or any other mechanism that can use that sort of technique. So when you do then get to do this jump starting, what essentially will be happening is you're allowing a high current flow to quickly establish, let's say a disequilibrium within the cell, that is to quickly reverse the the sulfation of the anode, the cathode that would happen if it is a lead acid, let's say, battery. Basically, you'll be reversing that so that you're able to establish, let's say the lead plate and the lead oxide plate, and get to bring back the sulfuric acid more or less into its, ionic existence within the cell electrolyte itself. So the input of that high current from a battery, which is, let's say, fully charged, allows this cell to quickly get into form, if I can say. Hence, if you jumpstart a car, you just wait maybe for a minute or two, it will then go on to, work on its own. And there's also an alternator, which then continues to charge the battery to ensure it gets, to that fully charged state. So in a similar manner, in this context then, since you're basically having one battery that is, let's say charging, and one battery that is discharging, if the reverse gets then to happen, whereby the discharged battery now more or less has to do the work, the other one more or less in quotes gets to jumpstart it. But then this jumpstarting, it has a slightly, let's say interesting twist to it. That is, it gets to happen in a quicker time, right? So the fact that it gets to happen in a quicker time, it then brings in the question, that you're asking, why? Is it something to do with the environment? Is it something to do with the switching? And I can safely say it's more or less a play of both, because initially this circuit, in its very own nature, it's something that is more or less existing in symbiosis with, let's say the quantum field around it. Meaning, as you are more or less changing maybe battery one into discharge mode and charge mode, it's also sort of having a ripple effect on the general, let's say space-time continuum that's around it. Meaning, instead of just being quickly charged by another battery, it also gets to quickly tap into the energy that's around it. And then it gets to, let's say recharge faster than usual. So the whole point of the discharged battery or a battery with lower voltage getting to sort of charge itself quite effectively and quite faster, it's not that that would be the most optimal thing, but then it was more or less an observation that was made. That why is it that even if, let's say, maybe a cell is discharged maybe to 50%, it gets to charge more or less as fast as that, which was discharged maybe to 75%. And I think that is quite something that is weird, because logically, if something is maybe, let's say, 50% full, generally it should take a slower time to reach 100 compared to something that is maybe 75% full. So it was just another interesting observation as well, that, which had to be factored into the story itself, that the system itself is more or less agnostic of the level of voltage or the amperage that is within the cell, meaning the effect gets to perform optimally well whether one of the cells is severely discharged or maybe partially discharged. And I think to any person who is very much interested in battery technology and maybe electrochemistry, that's something that is quite interesting, because it's a very strange occurrence which you normally shouldn't encounter, because basically the recharge time is more or less, proportional to the level of discharge happening, meaning the more the discharge the battery is, the more time it needs to recharge. But then in this case, it seems like there's that anomaly happening. And of course, it gets to be also pinned back to that occurrence of field manipulation, if I can say, by the circuit itself on its own.
Okay, this is really, really interesting. And Tapiwa, what is the key to extracting energy from the surrounding environment? Switching speed, the resonance, commutation, i.e. battery switching?
I think it's a play of, let's say a number of factors, because I don't think there is one factor that is sort of, let's say integral to the entire system itself. But I think the very unique factor, which I think observed and can place maybe as the primary, let's say, crucial point of function, I think is the switching speed itself. What you realize when you're maybe doing the Tesla 4 battery switch or the Bedini 3 battery switch, the higher the frequency of switching is, the more pronounced the effects become. I think in the very first question I mentioned that, essentially when one battery is getting to discharge, another will be sort of charging. So it simply means the higher the frequency of switching of positions, meaning it essentially means, one battery within a matter of, let's say milliseconds is charging. Then within the next few milliseconds is discharging. So more or less it remains in the relatively same position compared to the other one. Meaning if you look at it from an observer's point of view, let's say you were doing the experiment, you realize both of them don't really get to lose anything. They get to maintain the voltage, and over time, they get to recover. So I think the element to do with switching speed actually something that is quite unique. And the switching actually gets to be more, let's say optimal in the event that you use solid state switches. I think examples of unique solid state switches that a person can use that are more functional, I think they are MOSFETs. MOSFETs actually get to allow switching of a circuit at a level of microseconds, meaning you can actually explore a variety of frequencies of switching from as simple as 100 switches per second or 100 hertz to as much as 800 switches of on and off per second, which is 800 hertz. And another interesting observation as well is the higher the level of the switching frequency, the higher the level of the cell recovery and cell function itself. So I think in a sense that's something that is quite unique in its own right. And I think that's what essentially gives the circuit an added advantage over a normal connection, maybe of series or of parallel. So I think one of the key points that I had was in the process of expounding was how the switching speed itself gets to be more or less relevant in the context of how quickly the cells get to recover themselves. Because I think one thing which we have to appreciate is the fact that as you're utilizing cells, basically the voltage and the current, they all get to drop over time. But then, of course, if you had to implement a switching mechanism, they get to more or less establish, let's say, a very reduced level of dropping. And the more you increase, let's say, the frequency of switching, they get to establish more or less a stagnant let's say, level of voltage and current. And the more you keep on advancing that switching, they get to a point where they actually get to sort of recharge whilst effectively still in use. And I think that's one key point which I think would make me, I think, vote for, the speed of switching is something that is quite integral in the function of the cells themselves. But however, there's something also unique about the environment and how it influences the cell behavior. I think from personal experience, I've been doing these experiments, you realize something that with time, the cells get to sort of recharge differently, I can say. That is, in 2023, as an example, one general occurrence was, as the cells were in use, let's say, for example, without switching, firstly, they'll drop in a more or less uniform manner. And then once, let's say, you're done with, utilizing them, they then get to recover afterwards. But then I think in the year 2025, there's a very anomalous thing that I've also been observing. That is, two of the cells, they get to sort of maintain, let's say, a steady level of voltage or drop slightly. And then one gets to sort of like increase to like very high levels. And then when they rest, they sort of get to reestablish themselves in a very weird manner. That is, those that were working and sort of they dropped, the other two, they get to sort of recover to where they were. And the one which is sort of increased to a very high level within a matter of like a few minutes or a few seconds, they get to drop down as well. Itself gets to drop down to where it initially was. And that's very awkward behavior because it means more or less the quantum field itself, which this circuit depends on, is not, let's say, constant. It's not static. It's very much dynamic, meaning the quantum field has a very significant influence on how this circuit behaves. And perhaps maybe if in certain geological or geographic positioning on the other itself, perhaps maybe the effects are more pronounced than the other. But then I cannot certainly say that's the case. The reason being, of course, that I haven't been everywhere and tried all places to see how more or less the circuit behaves. But then I think it's a very weird anomaly. I was once having a conversation with a friend of mine, and he was giving me a hint, like, okay, what if maybe this has something to do with radiation X, the radiation, of course, that more or less affects our planet after a certain number of years. And I was like, okay, that's actually a very logical conclusion as well, because I think the observation that I made this year, it very much is in contrast with other observations that I've been making over the previous years. It's a very new one. So I think this circuit itself, just a point I'm just adding on above the questions which I was asked. This circuit is why I think it can sort of more or less be used as a means of exploring and also getting to sort of observe the quantum field itself. As humans, I don't think, in fact, I do know for sure we cannot observe how the quantum field behaves with our naked eyes. But then I think this circuit offers a bridge whereby you can get to sort of study quantum field behavior through effects that are observable in, let's say, a particular context, and are very much dependent on how the quantum field itself is behaving. And I think, the environment is always important. So I think those are the two main points that I would like to sort of set a hammer. That is the switching speed and, of course, the environment itself. I think resonance would add a slight advantage to how the circuit functions, but I think its significance could be sort of termed as secondary.
Tapiwa, one question came to my mind. Just being a humanitarian, I'm trying to understand how device works and what connections there might be. You were saying about the different charge in the cells or in the batteries, if I misunderstood. So a few questions. Does the amount of batteries help to balance the system? If you are saying that at different points of time, different cell might have a different charge, or it's just or the system itself that you've developed, does it need any batteries to run itself?
I think the core of the system, it still remains essentially a battery. I think the unique thing that is sort of brought about by this connection, because I think it's the utilization of the things we have in everyday life, the cables, the same batteries, the same gadgets. I think the only thing that gets to be different is how they are arranged. And I think that's what Tesla did with his 4-battery switch. And that's what John Bedini did with his 3-battery switch. And there's a guy by the name of Ron Cole who claims he can also work with a single battery as well. So they were just, let's say different configurations by different people, just trying to observe, I think, how this thing gets to more or less come into effect. So I can say people like John Bedini, I think they were in this field for more or less the experimental part of it to see how it functions. So they'll just play around with any number of batteries, 4, 3, 2, 1. But then one thing that I can say for sure is the effect gets to be observed with any number of batteries. So the whole, let's say crucial point to realize is instead of connecting a battery as we normally do, that is, let's say, for example, I think I have a small battery right here, right? Let's say, for example, this small battery right here, maybe I can just connect it and maybe connect an LED here. So instead of just connecting it in a way that sort of like makes it sort of discharge over time, let's say just over 4 hours, this circuit connection allows you to sort of realize more runtime. And at the same time, the battery gets to recover itself. So what these guys were doing, they were more or less bringing advantages of a new circuit connection that sort of allows the circuit to run longer and at the same time rejuvenate itself. So I think that's like the whole essence of the innovation that they were up to. They were just trying to, let's say explore a way of taking the normal functionalities of these cells a step further. So I think one thing people can get to appreciate is some cells are non-rechargeable, but then with this mechanism, they get to be. And of those that are also rechargeable, it means you won't have to spend as much time recharging them. So it's all about just enhancing the efficiency and functionality of the battery system itself. And I think they are all standpoint in terms of the innovation of the whole splitting of positives and tapping into the quantum field itself. I think their core philosophy was encouraging people to, let's say, rethink the knowledge systems that they developed on how batteries work. Because normally in schools, people are taught maybe, let's say, a series connection whereby it's the positive to the negative, positive to negative like this. Or maybe it's a parallel connection like this. Then basically they'll be powering a lot here. But then these guys will exploring the new connection that is the splitting of positives. Whereby you know if positives are in a circuit, maybe this battery being 24 volts, this one being 12, and then the potential difference being 12 volts out there, or also being a splitting of negatives as well. And when you do that, the cells behave in a very awkward manner that is not explainable using, let's say, the general framework of knowledge used. So it invites people to sort of explore how essentially the things we use in everyday life they can actually get to have the interesting and very useful effects that they have, which can be realized to a significant advantage actually. And that's what these effects do, because I don't think people in their mind had ever thought that, a thing as simple as a battery could effectively realize quantum field effects. But the fact that it does it is quite interesting. And that knowledge can sort of be expounded as well. It's not just to these electrochemical cells. There are many, let's say polarized energy systems that exist in nature. Even I think the neurons that make the various neural networks of various organisms. It can also bring a question that if an organism may have this sort of level of arrangement of connections in its neural network, does it mean an organism can now tap into the quantum field and realize something from it? Which would be a very interesting line of study, if I can say. So I think those are the two main things that the innovation was all about, reminding people that things are not as simple as they seem. There's always more to realize from the system. And the second essentially being, you can use the common things that you have to realize great advantages. Because such a circuit can even be utilized in general energy storage systems, mention power bank systems, mention UPS systems, you can even mention many other systems, even backup energies for, let's say, gadgets themselves. Because it's a very simple arrangement. So the innovation isn't in materials, because most of the times when people innovate, it's about trying to bring in, let's say, new ingredients into the pot, like cooking something entirely new. But then these guys were saying, even with the common things, a very common individual can get to sort of understand the mysteries of, let's say, of a unity systems or these free energy devices, as they are called as well.
Yes, thank you so much. It was very interesting. And you also mentioned about the splitting energy. So could you please explain what exactly it means? What is the physical meaning of the splitting positive energy?
So I think the name itself, it's more or less like a slang that was developed. It's more or less like what these guys just said when they just saw how the circuit looks. Because I think using the example of the batteries that I have, so when you connect, let's say, these negatives together, right, they're in continuation, and then basically you have this positive on this other side and this positive on this other side. And effectively, the circuit is broken. So for this circuit to work, you then have to connect these positives to a load. Just say the splitting of positives is just like an observation that you make when looking at the arrangement of the cells. That is, you have one positive there, another positive there, and the negatives are interconnected. And they just called it the splitting of positives. So it's more or less like just a general name given to it. But the interesting thing is, well, it can be called the splitting of negatives. That is, you can connect the positives in the middle, and at the same time, you have negatives out there. It will still very much produce the same effects. So I don't think it should be sort of treated as a technical or very scientific term, but rather it's just a general name given to something that a person will have the first time they get to sort of lay their eyes on this circuit. So I guess that's just the simple answer to the question, but making things complex in any way.
Okay, and you also talked a bit about charging pulse, if I'm not mistaken. So what is it, and why is it important in short pulse circuits? And maybe a few words about what are the short pulse circuits.
I think most people are more or less familiar with how charging works in different gadgets. So let's have an example. We're talking about a battery, right? Let's say you have a lithium-ion battery, maybe in your solar system. Basically, what you have is a solar panel, more or less harnessing solar energy through its photovoltaic cells, and then effectively converting that solar energy to electrical energy. Then you have a charge controller that gets to control how much current gets to flow into the battery. So that right there is just like more or less a continuous charge by basically ensuring a continuous flow of current at a low level. But then there's another technique of charging, though, that is existent, which is known as pulse charging. I think to make it relevant, I once gave an example during the beginning of the conversation. I gave an example of how a car battery can be charged when it is flat. That is, you can just bring in a battery that is high voltage current, you just connect it, and then you start the car. So when you do that, there's a pulse of high current or voltage that is effectively used to sort of reverse the rate of acceleration that would have happened, so that this battery gets to effectively quickly establish its potential difference, so that if it has this potential difference between its two electrodes, it then gets to more or less do effective work by producing, electromotive force. So when we are talking about pulse charging now in the context of this circuit, remember I said more or less they are switches. And these switches, they get to determine how current flows. So at one time, maybe current was flowing in a clockwise manner. And then in another instant, it'll be flowing in an anti-clockwise manner. So basically, there will be more or less pulses each of the terminals that are involved. So let's say, for example, using these batteries, which I'm going to be using quite frequently in this discussion. Let's say, for example, here there's a switch. And then at one point, if the switch is closed, the current basically will be flowing from this to that. And then if it's open, no current flows. But then if it's closed in the opposite direction, now flows from this direction to that direction. It means effectively both batteries will be having a chance to charge, but then it's happening at specific time frames and having a pulse of voltage and current occurring at a particular time frame in which that battery is charging. Meaning, let's say, for example, it's charging over a period of, let's say, 3 seconds. Simply means at the first second it's going this way. So during the first second, there is a pulse of current going to this one, so that is experiencing the recharging in a way. Then when the circuit is off, not allowing the current to flow in either direction, basically it's a deadline or the 0 point. Then if it is closed in that direction, it simply means it's not flowing from this one to the other one. And then it's the turn for this side to experience the pulse. So what you have, it's more or less a system whereby there are pulses of charges being moved from one to the other and from the other back to that one as well. And then it's more or less like an oscillatory mode. So it gets to be called a short pulse if you get to do this at very small time frames, maybe of milliseconds, meaning it's changing very rapidly. So it's not charging as continuous as what happens using a solar panel, whereby it's continuous flow of, let's say, the electrical energy or the current to sort of charge the battery. But then it's one battery sending a pulse to the other, and then the other sending a pulse to the other over a very short period of time, and hence the term short pulse. And I think it's more or less relatable to the example that I had given of how a battery gets to experience a charge pulse from another when you're jump starting a car. So it's very essential. Why? Because as we had mentioned, as these electrons will be flowing through the wire to that terminal, at some point they get to experience a jam whereby they're clustering. And at that moment when they're clustering, they get to more or less interact with the quantum itself. And then that quantum field effect is then what allows each cell to be able to sort of like rejuvenate itself and recharge. So it simply means if the jam is happening at this terminal at one point, then within the next coming maybe few milliseconds happening on the other terminal. Effectively, it means both of them are sort of extracting that quantum energy, if you can say, at relatively the same time. And hence, that's the essence of the pulse charging. That is to allow the jams to occur at both terminals, and at the same time as they'll be occurring at both the terminals, or the minute the terminals as they'll be involved in the context of the person, they go to more or less extract energy at the same time. And then what you realize is, as both cells will be working, the load is running, and they themselves, they get to maintain a very much constant voltage level and even recharge over time, which is something that is quite unique. So I think that's the essence of pulse charging in these circuits. It's not continuous, it's a pulsating charge, which means it's oscillating between two different points. And yeah, I think that's just it. So I think that sufficiently explains it in the simplest way possible, so that at least any viewer gets to understand what will be happening and why that short pulse charging is essential. That is supplying a high current within a very short time frame, so that they cluster and they get to extract that quantum energy and allow the cell to undergo reverse entropy and recover itself.
Yes, thank you so much for making it also simple for the viewers to also follow. And what is the role of diodes and capacitors in the Tesla circuit? What happens to them at the moment of switching?
So the whole point why in the circuits there are diodes and capacitors, essentially diodes, the electrical components that are used to sort of like determine the direction of current flow. That is, if current passes through a diode in this direction, it cannot come back. So it's there to determine that one side relatively remains the positive, and the other side relatively remains the negative. Because remember, we were having a system of cells that are having an oscillation whereby current is flowing in this direction and that direction. So in a way, that's an AC, but not really the proper AC we have in households. But in that context, since it's flowing in both directions, it's alternating current. But then some devices for them to function effectively, as in the context of these experiments, they are DC, meaning you need to ensure that one side remains relatively positive and the other negative. And what that diode bridge gets to do is, let's say, for example, it's like this. Maybe this side gets to remain the positive, and then this side gets to remain relatively the negative. Meaning if you have to connect a component, maybe it's a small LED, maybe it's a motor, the negative side will just go to this side, and then the positive side to this side. And that way, the device just runs as normally as it would. Why? Because it's experiencing a direct flow of a particular polarity continuously. And the whole point of capacitors more or less function like temporary short-term batteries. So a capacitor just stores charge. And let's say, for example, when the power supply is sort of gone into off mode, it gets to discharge its charge, which it is carrying, over a short discharge time. That is, it ensures more or less an evened out flow of current or voltage, regardless of the switching. So as we'll be doing the switching, becomes a point whereby it is like a flat line. Because remember, if electrons are flowing this way, at some point there has to be that point whereby they're no longer flowing that way and they're now flowing this way. So the whole point of capacitors is to sort of provide an energy provision in that instant, whereby there is zero flow in this way or that way. So what they essentially do is they still continue to supply a short pulse to the components that are sort of being used in the experiment. And at the same time, when, let's say, the current now flows in the opposite direction, they just get to store the charge again and wait for that next moment. So I think capacitors are more or less functioning as some sort of like a short-term backup mechanism, just to ensure charge supply isn't disturbed. Yes, of course, the switching will be getting to happen either on or off. And the diodes themselves, they're just there to ensure, the polarity is sort of maintained, with one side remaining more or less permanently positive and the other negative, and having a DC device being connected. And I think that's the whole essence of those components that are involved. But another interesting observation, though, is if you are to remove, let's say, the capacitors, more or less it will work. I don't think to the naked eye, the effect will be that much observable. That is, if the switching is very fast enough, you won't even observe anything. So the capacitor is just more or less for standardization of the experiment. But without them, yeah, you still realize the same effects. But then I think the most vital thing will be the diodes, because without the diodes, you'll more or less be having an AC system. Meaning, if you to, let's say, connect an LED, it'll be blinking like on and off as the directions change. But then to ensure it's constantly on, you then need that diode bridge. So you can actually do the experiment or the observation without these things, but then it won't be as smooth as when you have those things. So those components are more or less functioning as essential utilities to ensure that the entire experiment gets to happen anyway.
This is exactly what came to my mind. You like pretty much answered my question, is that if the energy is pulsating like that in the battery, then how do you make an output for like other devices to get charged? You need like some capacitor or a voltage converter or something that will streamline the flow of energy. And another question was if the charge in the battery is always like flows and pulsates, won't that influence the life of the battery?
So I think one thing as people are doing this thing, you have to appreciate, I think, is the simple fact that the gadgets which we use, they come with a lifespan. Even the batteries themselves, they have a lifespan. If you're using a normal lead acid battery and you're going to use it intensively, normally its lifespan is given between 3 to 5 years. So the splitting of positives doesn't really get to change the lifespan of the thing itself. What it gets to do is it gets to make it, function in a much more efficient way in regards to meet our energy demands. So let's say, for example, a manufacturer had made, hypothetically, a low-quality battery. I actually can say we are not going to change the fact that it's a low-quality battery. It's going to just last as long as it should. Because I think just like any other electrochemical cell system, it gets to come with a certain number of set life cycles. So the cycle's lifespan, if it's exhausted, more or less, there isn't much you can do about it. And I think that's why manufacturers encourage this thing called depth of discharge, meaning when you're using a battery, normally you're not encouraged to put it below 50%. The reason being, if you really exhaust it that much, you sort of quickly wear it out and it really gets to exhaust its possible lifespans of charging and recharging, which is whereby at some point you get to have this battery whereby if you charge it, it just quickly loses its energy. And essentially, yeah, that's just gets to show you that the lifespan is sort of been met and it's just time to change it. So I think the splitting of course in itself, it's a very unique phenomena. But I think for it to have greater utility, to also call for production of cell systems that they themselves are more robust and more pronounced in how they function and get to do whatever they'll be doing.
Okay. And as far as I know, Electrodyne Corporation tested the Tesla 4 battery circuit for 3 years. Do you know what results did they achieve?
The information on what Nikola Tesla did, at least in this context of these other extraordinary, feats, it exists in underground communities, if I can say. I think most of my, let's say, articles I get to sort of like compile for research, they stem from underground, science communities. Mention sites like Rex Research or Over Unity Research. The claim was when he discovered this, 4 battery switch, essentially, certain individuals were intrigued by how it functions and included this corporation, meaning they just had to bring him in and observe how it functioned. And as per the claims, they actually ran, the trials for quite a couple of years. It was working out, and the batteries were simply, let's say, living as they were supposed to. Meaning, if, let's say, for example, 2 batteries were bought in the same year, and then this one battery was being used in this circuit, and then this battery was used in other things. Basically, after, let's say, maybe the 2 years, if they were going to be brought together, they were just basically showing, the same health, if I can say. That is the functionality of a battery, which is expected after the 2 years. So that's a way of verifying or sort of reaffirming the fact that this effect in itself does not sort of impact the lifespan and the health of these cells themselves. So that was the whole point of that encounter, whereby it was the person who had this invention, that is being tested, interacting with another party in need of a service, which was this corporation, and then this event occurring that was sort of mutually beneficial for both parties. And at the same time, having a very successful outcome. So that was like the whole point of that recollection. But then to say it's something that's provable, I don't think you can even prove or disprove it, because it's something that happened beyond the era of collecting such information on the net itself. But given that Tesla had done a lot of these things, and given that the circuits themselves are functional, it's more or less plausible to agree with the claims as well, given, of course, the things we should also be observing on ground. So I think that's what I can say concerning that encounter with the hydrogen corporation and how everything else functions. And I think I would also just love to encourage people to just go out there and just sort of enjoy scavenging for information. Because I think as you're having this interview, right, I think if you simply go on Google maybe and you type splitting of positives, I think you realize that the results that you get there, they are extremely different from what I'm saying. So it simply means if you want that extra information, which is not common, you have to go the extra mile. You have to go where people don't normally go. So you have to read those things people don't normally read. Because I do know there are a lot of biographers who talk about the life of Nikola Tesla, but then most of them, they don't sort of like talk about those other sort of weird things and other unusual things and other inventions that he came up with. And I think this is one of them, because people may speak of recent developments of, the AC concept and the functionalities of the AC motor, the remote control systems, the wireless transmission system, and everything else. But this kind of thing is omitted in most biographies, meaning, it's not something that is like that was more or less accessible to these guys who are doing it. Meaning, as a person, you also need to sort of like do your own research and be hands-on with these things.
Yes, thank you so much. Earlier we discussed about the Tesla circuit, but to give a little bit of more clarity, could you also give us explanation on how does the Bedini circuit differ from the Tesla circuit, and what advantage does the new circuit offer?
When Tesla did his circuit designs and everything else, surprisingly, he started off with the number 4. Right? So I don't think there's a way for us to change that fact. He worked with a number of 4 batteries. So I think people like John Bedini, they're coming from a perspective whereby they were saying, do we really need 4 batteries to make this thing work? And Bedini then proposed this model of a 3-battery system, which essentially just works as good as that one. And a few years down the line, you also have people like Ron Cole proposing their single battery, just working with capacitors to achieve the same thing. So what you then get to realize is the simple, let's say understanding that these guys, they were more or less people who were into science because more or less it was a part of their lives. So some of the things they did, it was out of genuine curiosity. And I think I can safely say that for John Bedini. John Bedini, there are many recorded symposiums that he had. I think if a person scrapes around on YouTube, you get to see some of them. And there's a guy who just explored various circuits, even got the Schuylkill circuit, his 3-battery circuit. He was even proposing the making of what he termed the price of batteries themselves. And they were an interesting concept. And for him, normally what you'd say in his sort of like endeavors or researches was, the whole essence was for him to show the world a new way of seeing things. So John Bedini was a man who was about opening the eyes of people to new realities. So in what he did, it was more or less about what will happen, just for the curiosity's sake of it. However, these 3-battery circuits still has advantages. I think the main advantage is it just has fewer batteries, which is, I think, the obvious thing, because Tesla had 3. So that's or observable advantage at first glance. And I also think in terms of the general circuit arrangement, it's easier to follow the Bedini connection than the Tesla connection. But then I think, as I said, as I had said in the beginning, you can use any number of batteries you want, but then the effect still remains the same. So I think for Bedini, it was just him exploring what would happen in that instance. But then the results, they just get to be very much similar to the ones you get using the 4 batteries. The difference being this is simpler and it's much more just easier to sort of connect for any person who will be willing to replicate it as well. It's very much clear and understandable. So I think if someone is now trying to be economic about it, I think the best option maybe would be the Ron Cole 1-battery model. I think that's what would be much more economically viable, as we can say in today's terms. And I think it will just give you, I think, very much the same satisfying results as base capacity, because you have to remember as well, if you have a 12-volt maybe 30Ah battery, you can't expect it to go beyond 400 watts. So it simply means it will work within that frame it is in, but at the same time, it's able to exhibit those same effects of being able to function continuously and recharge. Meaning, if you want to go further, you simply need a bigger battery and stuff like that.
Thank you, Tapiwa. And one more on battery charging. How did you determine whether one of the batteries was actually charging with the classic voltmeter, a logger, or an oscilloscope?
So I think normally when you do this kind of experiments of observing maybe voltage behavior and current behavior, the most recommended thing is to have a multimeter and an oscilloscope, or an oscillogram, as I say, both there, so that you really get to visualize how, of course, the current is moving and the voltage is moving, and at the same time get to have readings using, a generally used mechanism. But for my context, I used a multimeter. I think I was more or less approaching it from a hobbyist kind of thing, because I was just interested in just seeing how it behaves. But I think to make it more standard, like for compilation of, let's say, state-of-the-art research, then definitely you can use both. But then one thing for sure, though, the effect doesn't get to change. What just gets to change is, I think, the amount of data that you have to sort of validate the effect itself.
Yes, thank you so much. And yes, now we would like to more discuss about your free energy device. Could you share with us which methods did you use to measure the system's efficiency, and what results were obtained?
So I think to any person who is, let's say, more involved in, let's say, these free energy things, I think one key question which you have to sort of ask yourself even before you begin anything is, how would this be different from what is usually observed? Because let's say, for example, it's just an example. If a battery is to run for 9 hours, then you do your connection and it runs for 9 hours. You can't really have a substantial ground, to claim that there is realization of a unity or a coefficient of performance that is greater. Meaning, the performance is more or less based on what the battery was supposed to do before this thing has been done. And once the thing has been done, what has it been able to do? Meaning, if you're going to let's say, more or less going to have a very conclusive outcome, the very first thing which you have to sort of, let's say, venture into is basically understanding the health of the cells that you have. And I think to do this, you do a number of simple tests. You can do the simple capacity test, whereby you check, your cell, and you really get to evaluate effectively whether it really has, decided voltage and current levels, and whether it can actually deliver them at such levels. So you can even check a load. Maybe if you have got your 12 or 30Ah battery, maybe you can even use a load that draws maybe 1 amp per hour, and then you get to see if you can really last those 30 Ah or 30 amperage hours as is claimed. If it does, so it simply means truly it has that capacity. So you can even go on to do a load test, whereby we get to sort of make it operate at the maximum level that it does. Meaning, if a cell is supposed to be giving out, let's say, for example, 360 watts of energy, if I connect, let's say, maybe a load that roughly functions close to that level, it should be able to power on, meaning it really gets to deliver that amount of energy as well. And you can even get to do an open circuit test, whereby you get to really see if the potential difference that is written on the cell itself is really the one which is observed. And you also have to do an internal resistance test, whereby you have to understand and evaluate if truly the current is flowing without impedance. Because normally batteries, they come with an internal resistance that is in them. Normally it's very low if they're like high quality batteries, maybe 1 to 2 ohms. But then sometimes you realize you may get to have a battery that has a slightly high internal resistance. That will also get to generally affect how it functions. And it also just positions it in, let's say, a lower evaluation when it comes to evaluation of its health. And I think you also have to sort of generally do a self-discharge test, whereby if you take your battery, let's say, for example, it has 12 volts and 15Ah. If you put it somewhere for a week, if you come back, does it still have the same readings? So all of these tests, they are sort of essential in understanding more or less the health of the cells which you're working with. Because I think for you to make a conclusion that, these cells are exceptional or something else has been realized, you also have to prove that you're working with things that are more or less standard. And you need this test to verify it. So if your tests more or less match the manufacturer's claims, which means you're having healthy cells which are functioning. And now once you do the test, you have to more or less do it the traditional way which we do in science. That is, you need to have a control experiment, and then you need to have like the standard experimental trial that you're going to be doing. So in the control, you can get, let's say, take a simple 9-volt battery, 100 maybe 1,000 milliamp hours. Maybe you power a 5-volt DC motor. You then get to sort of study how the cell behaves over time when it's powering that load. You note the voltage behavior, how it drops, the current behavior, how it drops. And basically when it comes to a stop. That way you actually have, let's say a full profile of how basically the cell gets to happen. So once you have a full profile of how the cell behaves and the kind of energy that it can get to deliver, you then translate that to experiment now. So in our experiment, let's say we now have this unique connection that we have. We're now going to observe, will it really last longer than what was observed in this control? If it does, that means, well, there's a reasonable, let's say ground to then further investigate if there is need for a combination of data to prove the overunity. Then you also get to prove as well, if the cells get to recover, how different is it from the normal, let's say cell recovery that gets to happen? Because normally if you're using, let's say, alkaline cells, they get to exhibit something known as like a recharge effect. That is, even if they're used, if left, they just get to slightly go up a bit. But then if that recovery is done, how exactly different is it from this usual? So I think one trial, which I effectively did to compare all this data, it was more or less using, I won't mention the brand, I think just for respect of, company, but I was using solid cells from a particular company and the 90-volt cells. So I bought 4 of them. It was a simple trial experiment. I was using those 90-volt cells, a breadboard, a couple of LEDs, a 5-volt DC motor, resistors to control the current and everything else. So basically it was a duplication whereby you've got the experimental run here and you've got the control here. So in this control, we have 3 batteries. We know maybe it's supposed to run for 5 hours, meaning if these batteries are to be connected in series or parallel, it means they're not supposed to go beyond 15 hours at most, powering a load such as that 5-volt DC motor. And in turn, if you're going to use this of a unity system of ours, if it's going to go further, then it means, well, it's something that is actually quite significant because compared to the control, it has done something that is not expected of, let's say the parameters given to the device itself. So in that trial run, which I did, it was quite amazing because instead of just outing it around that 15 to 16 hours, it went 21 plus hours. That was something that was quite impressive because it then becomes anomalous that if the runtime was supposed to, let's say, be X, if you now have maybe, let's say 1.3X, that means, well, something else is now being tapped into. And at the same time, after the trial runs were done, the cells have to be evaluated in terms of their standpoint. So these 3 cells are basically used in series. Once used, they are dropped to maybe, let's say voltage levels of around 4 volts. And then the ones that were more or less used in the unique connection that was meant to realize over integrants, they're all more or less getting to recharge as well. So that trial run more or less gets to prove at a small scale how, let's say the experimental run is more or less effective. And I think that's how I did my, let's say test of overunity. It was more or less an evaluation of what happens at a small scale. And then we simply scale it up. Because I don't think, in fact, it is a fact. The physics of things doesn't get really to change if you just scale things up. Meaning, if you had to use a small battery to power a load, even if you use a bigger battery to power another load, the physics still remains the same. And for a more conclusive, I think, and economic evaluation, it'll be much more wise to do as many connections and as many experiments you can do with small things because you can actually get to afford to play around with those things and get to experiment all possible connections in a very safe way and get to make the very logical and very understandable conclusions at that small scale. And then basically when you have this bigger system, it's just basically scaling up by a factor from this small scale to a bigger scale.
Okay. Thank you, Tapiwa. We are basically moving on to the practical part. You provided a list of components used in your system. Let's show them on the screen, please. I think viewers interested in replicating your system will be very grateful for this. And we would be interested to read their results in the comments. Also, dear viewers, you can send us emails at the address shown on the screen. And Tapiwa, please tell us what criteria did you use when selecting these components for the circuit, and what were your main considerations on this?
In terms of, let's say, the general experiments that I do, I think I'm a person who works with the philosophy that, more or less, knowledge is provisional. That is, it changes over time and you have to adapt. And at the same time, the experiments, they more or less get to stem from necessity. So for me, it was more or less about research and understanding how these things were behaving. So the initial time, they were just the small scale thing. So the next time, then I just chose to sort of establish what I could call maybe my own free energy mechanism per se. It was more or less just scaling that thing to a level which I could normally evaluate it as. So normally, I think as a person, my gadgets at most, which consume the most amount of energy, maybe you can talk of televisions, maybe a stove, maybe a refrigerator. So I think given the kind of laws that I had, they get to sort of, let's say, influence the kind of power source which I could sort of utilize. So I couldn't, let's say, buy 48 volt 200 Ah batteries because, well, that is way over the kind of things which I could, play around with. So for me, my main, let's say, influencing factor in the kind of components that I chose, it was more or less to suit the context in which I was the experiments. But I think to all the viewers, I'd like to let them know that it's not limited to what I chose. It's more or less also relevant to your standpoint, the kind of energy which you want to realize, and the kind of components that you can best get your hands on. Because let's say, for example, for the switching. For the switching, at some point I was using electromagnetic relays, which are more or less mechanical switches. But then you realize you can even use solid state relays, which are even faster. Maybe you can even use transistors, and you can even use MOSFETs. So there isn't really a limitation to what you can choose. But then I think it's more or less relevant to the kind of result which you want to have and what you have to do to get that result. So for me, that was the kind of conversations that I was having, because in my mind, I very much understood the kind of loads which I was dealing with. I understood the maximum supply which I actually needed to actually get to do those, let's say trial runs and experiments. And for me, those simple 12 volt 30Ah batteries could actually do that magic for me, if I can say. I could light my screen, I could run one or two things in the house, maybe a laptop, maybe a computer. This was all more or less convenient for the kind of scenario that I was in. And I think that's one thing that I'd also love for people to also understand, that you don't have to copy and paste, because I don't think you have 100% similar situation, which I have, wherever you are, meaning you have to understand the concept firsthand. And then once you understand the concept, you then get to choose the right kind of components that you need to scale to the kind of things that you want to power. And I think that's where it gets to be easy. But then I think the general layout is simple. You have to identify a sufficient power source if you're going to be using electrochemical cells. And you have to also understand, you have to use the right kind of, wires if you're going to be doing the connections, because wire thicknesses is quite an important factor. You don't want them to heat up due to a high current, maybe in a very thin wire. And you also need to understand the kind of diodes which we are using. Does the voltage and current level match the kind of diodes which you'll be using? And the capacitors as well, because capacitors, they actually have a tendency of blowing up if they're overloaded. So you also have to understand that as well. So safety is important. And I think you also have to also factor in the kind of power which you need to do. Is it going to be the direct current mechanism, maybe powering a DC motor or something like that? Or perhaps you want to use it and maybe have an AC current, maybe powering a television or something else. So once you understand just that general layout, I think you can then find the right kind of components to fit in each, I think, let's say in each frame.
Thank you so much. And could you please describe step by step how to replicate your installation at home for our viewers?
So I think one key thing, which I've already said, is you have to sufficiently understand the kind of power supply you need, meaning you need to have with you the right kind of components. And I think the general step-by-step of your give is like this. Number one, you have to make sure that you're handling, I think, high levels of current and voltage with the required safety. Because short-circuiting the cells, not only does it pose a danger to the cell's life itself and its health, but it also gets to endanger you as the kind of person involved in this. Meaning the right kind of safety gear and the right kind of, let's say, etiquette is required when handling these things. So I think the very first thing which you have to do is you have to craft out a well laid out circuit diagram of how you're going to do the connections. Before you can do it in practice, you have to visualize it in the mind and put it somewhere clean and neat so that you really understand what you have to do. And I think it'll be more easier to do it step by step. So I think the first kind of step which we then have to attend to once the circuit is well laid out, one is more or less similar to the one that I have. It's about structuring the power supply itself. Are you going to do the right kind of connections, and how are you going to do them? And how are you going to secure the connection points as well? That's a very key thing. So it means if you need cable connectors, if you need cable ties, and if you need shrink wraps, you're going to have to do that as the very initial steps, such that this power supply itself is solidified, and it's actually something that is, let's say put. Then once it's done, the next thing then becomes, are you going to effectively structure the load? And how are you going to connect it in a way that is safe? Meaning, let's say, for example, if you're going to be using an inverter, you have it ready, the terminal is ready, and maybe you should also provide an output, maybe to a surge protector and everything else. That should be done. Then once those two mechanisms are done, you now need to simply do a test to the power supply. Is it producing the kind of voltage and current that you as a person would want to work with? That you can do with a simple multimeter and do the test. Because before you connect, you have to know what you're dealing with, and if it's coming out as it's planned. Meaning you have to know the polarity as well of the connections, because even though they are the spectrum of positives or the spectrum of negatives, one side gets to be relatively negative to the other, meaning they'll still be negative and positive, and you need to find them out. Once you have them, you have to make sure that the positive is going where it's supposed to be going, as per the circuit diagram, and the negative is going where it's supposed to be going as well. The cabling now has to be done, which is more or less like the bridging between the power supply itself and the components. That is the system of the diodes and the capacitors and the switches. And I think the best way to do this is you can actually have a moment where you can structure the bridge separately, because I think connecting the diodes, you can do it in an easy manner using your own soldering gun, soldering wire. Or perhaps if you have a printed circuit board, you can even do it whereby they're all laid out as the bridge. Then what you simply have to do is now you take that bridge and you put it between the power supply itself and the load. Meaning it's just a simple connection of to the power supply and to the load. And then once you do it, you should do a simple test, not something which strains the circuit, but something quite simple to see if the voltage and the current are flowing in the way that they're supposed to, at the right levels they're supposed to. And I think if you simply do that, you then get to know if you then get to scale up. So you don't start at 100, you scale up bit by bit, observing if everything is functioning quite well, because you never know, maybe the kind of cabling you're dealing with may be a bit too thin. So you have to also observe the temperature of the cabling, if the cabling is actually able to handle the kind of current that you're using, and if the diodes are functioning quite well, and if everything as well is in shape. And once you do that, I think as with the general replication of your circuit diagram, it will be well. Once you are confident that things are working well on this prototype which you have made on the side, you can then now attempt to do it maybe on something else, maybe in your household, and trying to play around with things. At least you'll be knowing what to do. And I think a very important factor, which I always, I think, underline is you should improve proper installation. Because I think poor installation can be a danger, especially when you're doing with anomalous flows of the right kind of gear. As I've said, if you're going to be wearing gloves, that'll be good. And if you're going to be using shrink wraps to cover up any possible, maybe stray wires, that'll be good as well. And I think once you do that, that'll be okay. And I think if you also just get to use some protective equipment from surge protectors to circuit breakers, that'll be good.
Yeah, important point actually you mentioned about the protective equipment, because it was coming to my mind as well when you were saying about like experimenting and trying to find something else, or other inventors who just tried what if I do like that. So I think it's really important to mention to our viewers that, guys, while you will be experimenting, make sure you wear like, I don't know, rubber shoes, rubber gloves, or what's like usually required. Tapiwa, are there critical requirements for connecting the useful load? For example, connection order, polarity, conductivity, some of the things you mentioned already, but maybe we can mention a few more things on this.
I genuinely do think polarity is something that is crucial, because I think for the second arrangement to work, overall, I think it has to be within the right order. And order, when it comes to circuits, it's all about polarity. So I think the very primary thing which a person has to observe is if positive is where it's supposed to be, and if negative is also where it's supposed to be. I think if that's the case, it'll be good to go. Conductivity is also something that is quite good, because I think the more the conductive the cabling that you're using, the more smooth generally the circuits get to function overall. But then I would like to mostly stress on issues to do with polarity. Why? Because even though you're dealing with splitting of positives circuit, one thing for sure is at some point, electrons are moving from maybe point A going to point B. And you also need to make sure that these points are predictable and they're well understood. Because if they're not well understood, it's either something which you don't expect to happen or something bad to happen or nothing will happen. I don't think all of those three are things that are crucial if you're going to be doing this. So I think polarity has to be strictly observed. And I think you have to be sort of very much careful. And as I previously mentioned, it's always better to start small and then scale up.
Yes, and regarding the safety, as Sergey mentioned, I have also a related question. Which measures do you recommend to use to protect components from the overload in the event of the sudden voltage spike?
So I think it's a very much serious, problem that exists. 20% who is into electronics, you always have that worry if the current isn't a bit too high and if the voltage also isn't a bit too high. So if you're dealing with maybe, let's say, a DC system whereby, it's maybe a simple battery and the motors involved, I think the key components which you can use maybe a variable resistor, that is to regulate current flow into the components. And I think another vital thing as well will more or less be the use of fuses. I think most, let's say 3-pin plugs, they actually get to come with this sort of like inbuilt systems or inbuilt mechanisms through the fuse, of course, which gets to sort of burn out in the event that the voltage and the current are above the required level. But in the event that you're doing it at a small scale, maybe for the experimental part of it so that you understand, I think if you've got a couple of resistors with you and maybe a variable resistor as well, maybe potentiometers, that will do you in terms of safety. Then when you scale it up to a system, maybe that requires the use of AC, I think a circuit breaker is quite important, because what a circuit breaker simply does is it breaks the circuit when something is off, which is, I think, quite straightforward. It does it by itself. It's already like preset to maintain it. The person can even get to use surge protectors, which are more or less connection mechanisms between the electronics which we're using and this circuit, which more or less gets to sort of like observe a very much stable flow of voltage at the required level. And of course, as I've said, most of these devices as well, they may get to come with 3-pin plugs that have like inbuilt fuses and stuff. And I think another thing as well, if you want to go a step further, you can even consider the use of what you would call, transient voltage suppression diodes. What these things basically do is they get to ensure that the voltage is more or less tuned into the right voltage, meaning even if it is up, it will get to be tamed into a level that is useful for these devices. And I think more or less, these are the options that are very easily available. I don't think if these are used, anything will definitely go wrong. Even use of metal oxide, maybe diodes as well, which get to ensure that maybe if something wrong gets to happen, it's earthed. So also just make sure the things that you're using, they have got earthing. That is, in the event that maybe it's actually hypothetical, because one of these things which I've mentioned, they can be used to effectively, let's say, curb the problems. Most of the options, they're very available, I think, in electrical stores, which you can just get to, and you can just give them the specifics that I'm trying to maybe the detail level of this voltage and this current. Is there something along the lines of things that I have said, which you can give me, which I can put in my circuit to ensure that if it gets to be above that, it's pushed back to the proper limits, well, basically the circuit gets to be broken, and the issue has to be fixed before it can be run again. So I think in terms of the safety of components in the circuit, that will be it.
Okay, thank you, Tapiwa. Can you share with our viewers what were the most frequent breakdowns and mistakes during the development and testing of the circuit?
I think mistakes are sort of dependent on the individual. So I might have made them, you may not make them. You may make your own new mistakes. I think that's one thing as well. But then I think in my context, I had a problem whereby, you have, let's say a preconceived image in your mind of how things are supposed to work. So if you're going to connect something, if you have got your own understanding of how you think it should work, normally what you do is your subconscious mind will make you connect things in the way you wish for them to be, not what's it's supposed to actually be. And I think as a person who was experimenting with this kind of stuff, it was the key problem of observing proper connections, because in your mind you're like, is this really it? It may not be it. So I think a key thing which people have to accept is during the first time you may make a number of faulty connections. Yes, you'll be observing the diagram and you'll be trying to do it right. At some point, subconsciously, you can even make a connection that actually is not supposed to be the way it is. Why? Because it's a circuit that is experimental. The way it works is just strange. When humans are sort of, let's say confronted by a situation whereby they are dealing with the strange, it's more or less the tendency of the mind to more or less revert to what they commonly know or what they think should be. So subconsciously, you may want to replicate what you think should be when you're doing it. And I think if you closely observe the circuit, you may even notice that's what they got. Okay, I did this at this point, but honestly, I want to do it. It wasn't per the circuit itself. So I think it's mostly a problem of observing the circuit and building it step by step, trying to make it, as fast as possible using possible things I know. That's one, let's say, disease that most people have, which I think if they observe, can get to be controlled. And I think another issue as well, which gets to occur, mostly it's about, let's say understanding of how efficiency of, devices at the power supply are sort of interoperable. So I think sometimes people may underestimate, let's say the kind of energy consumption of the things that they're going to be powering, such that they end up buying things that, produce a less amount of energy. They'll realize perhaps maybe, since if they may be at a 90% efficiency level, it may not really get to effectively power the kind of devices that they're having. So I think that's thing that I mostly, made a blunder on. I think the very first time I did, it was more or less underestimation of things. So always make sure you do the proper calculations and you really understand the kind of energy you're going to be producing and kind of energy that's going to be going. And at the same time, you also have to leave room for, let's say provision of extra energy in the event that is required. Because it simply means things don't have to be, let's say exactly as they should be. They should be more or less at a certain level that's more or less expandable in the event that a slightly bit more energy is required, or maybe a slightly less energy was doing as well. So I think those are the two key things that we have to observe. And I think the third thing, which would sometimes, I don't think it was a very common thing, but it was a very rare thing. I think it was an issue to do with short-circuiting of cells. So sometimes when you're doing the connections, you may be absent-minded, and you may just get to short-circuit the kind of batteries you'll be using. That's just not, a safe thing to do. Of course, no danger will be mostly realized, but it's just not recommended. So I think for me, those were the mistakes that I had, and I think the best way I ironed them out was just by doing the best thing possible.
Yes, thank you so much. Indeed, sometimes in mistakes you can find your own truth, right? Another question we have, how long can your circuit run continuously without intervention? And did you experience overheating of components or self-oscillation?
So normally if you're going to be using, let's say, ordinary batteries that work the way they should, no overheating is experienced. And I think if you're going to be using things like an inverter, you have to accept the simple fact that an inverter naturally it heats up as it's working. And that's why inverters have got inbuilt cooling systems, because that's just as it works. So it simply means things that are supposed to heat up will heat up. There's nothing you can do about that. However, I think in terms of the power supply itself, that is, the cells that are used within the system, they didn't exhibit any form of stress and strain as per the use. And I think in terms of the duration in which I ran this circuit for me, I was sort of observing the manufacturer, let's say guidelines of how long devices are supposed to be run. So let's say, for example, inverter, it's recommended for you to do a 12-hour run with it. I would more or less do a 12-hour run with it, give it a break, then run again. So for me, it was more or less like a strain test whereby I was running them 24/7, maybe throughout the entire week. If I was going to do trials during a week, basically they'll just work when I'm doing the experiment. Let's say, for example, it's the morning and the afternoon. It's 6 to 6. Then maybe in the evening when I'm done, I'll just switch them. However, I think if the systems that are recommended for 24/7 running, because the inverters that are meant for that, I don't think it should be a problem, because the cells, they get to recover on their own and they more or less get to do the work. But then at the same time, I think you should understand as well the kind of components you're using, because some components as per the manufacturing guidelines, they're not supposed to work like continuous. If you had to use a house meant for 24/7 running, inverters used for 24/7 running, it shouldn't be a problem. Your gadget should work well. And I don't think there's also a scenario whereby a person gets to use energy 24/7, even in a household. Even if you have got your own household, you won't be lighting the TV 24/7. I think maybe the only gadgets that may be functioning 24/7 are lightweight gadgets, maybe the refrigeration system, and maybe the charging system, which I think even if they are to run 24/7 continuously, they don't have an energy demand that's in quite significant in a way that affects the supply itself. However, I haven't really got into a scenario whereby I was running at maximum supply, whereby, let's say, for example, a kettle is on, the stove is on, a TV is on, and it's continuous. Basically, because with the nature of research, the nature of person I am, I don't run things in that continuous manner. But in the event that it's going to be done, I think, as I've already said, just observe that the components you're using are meant for the strain testing and for longevity or longitudinal researches of such sort. And then I think everything will be okay.
Thank you, Tapiwa. What key factors must be considered when scaling the system from 12 watts to 1 kilowatt?
It's the number one fact. Are you understanding how the circuit is working? And are you understanding the proportion between the power supply and the power consumption? Right? So once you have the proportion, it simply means if you're going to be scaling up the power supply from the 12 watts to 1 kilowatt, it also means the loads have the same proportion as well. So I think that's what should be said in simple terms. So I think if you want to do a replication for a 1 kilowatt system, I think you can do things at a small scale. I think I always prefer doing, find those small 9-volt batteries which can give you a total output of 12 volts. Use the resistors and maybe other things to represent maybe control mechanisms and safety mechanisms. Get your diodes. Maybe in place of an inverter, you can find a buck converter that works at those small levels. And maybe run a motor and maybe an LED and other things to represent the household. And observe how those things relate at the small scale, maybe of the 12 watts that you'll be dealing with. And once you've effectively understood how things are working out in that small scale, what you have to do is just to increase the proportions.
And have you tried integrating it with the inverter to obtain an AC power source?
Well, yes, definitely. I think it wouldn't be justice to just do DC experiments, AC experiments. I think that's also the whole point of using the diode rectifier bridges to show that even a DC, inverter, because inverter basically just converts DC to AC. So it simply means the terminals more or less have to have a constant supply of that voltage and current at a particular terminal without interruption. Then the inverter just gets to convert it. So in my case, I was using a 600-watt inverter, and basically I was doing trials with monitors and lights, which of course the 600-watt inverter is sort of pegged to be able to support. And the very weird thing which you realize is you can actually connect the inverter directly to a battery without going to that diode system. So what you observe is even though you draw energy from a single battery, more or less it just gets to recover as long as at that, let's say splitting of positives output, something is right. Meaning, let's say, for example, you can find your own small DC fan or a DC motor, then you run it at the splitting of positives terminal. Then you can actually connect your battery at any choice of the 3 batteries. So you can start with battery 1, battery 2, or battery 3. And what you observe is even if they work, they simply get to rejuvenate. Why? Because they're still adding something using the splitting of positives, and the current is actually able to change direction. And in a way, they're still recharging as they should. So I think connection of an inverter isn't something that really changes how it functions, because already by nature, an inverter is supposed to take in DC, of which this circuit by nature is providing that DC. You just have to make sure it's the right connection, positive to where the positive should be, the negative to where the negative should be. Or if you want, you can take the inverter directly to the batteries themselves one by one, and still it gets to function as it should.
And do you have data on battery longevity in your system? How much longer do they live compared to regular use?
My batteries haven't gone out of use yet. I think they're still functional, because I think the lifespan was that of 5+ years. So I don't think I've done already 5 years yet. But then I think I do, as I have already mentioned, the normal tests, whereby if you have to take the battery, that is to have the same open circuit voltage after fully recharging as it should. Because let's say, for example, if you're working with a 12-volt battery, normally if it's fully charged, it should be somewhere close to 12.6. That if it's health is still really optimal? And does it experience any self-discharge? If left alone, does that battery just start to lose, its voltage? If it gets to maintain its voltage, it means the health is quite good. Is it exhibiting any signs of internal resistance? Because maybe people may assume that if you're doing the splitting of positives, maybe the sulfation of the plates of the cells which are sort of staked within the battery itself. So it simply means if the internal resistance isn't going anywhere above the industrial specification, maybe of a single or 2 ohms, then it's good. Then if he is able to lift the same loads as it does, then good. So I think that data I do have, because I still do have the components, and I still can do the evaluations again as well. And I think I can share as well the documents which I have done, those evaluations at some points. But in general, the batteries are living as they should. And I think that's a win, which is actually great, because if you get to realize greater benefits and at the same time get to maintain the integrity of the device or the source, then that's a thumbs up, which means you are just using it as it should, given it's meant to actually provide energy. But then it's just an awkward circuit connection, which provides these extra advantages.
And do you plan any further research and modification of this configuration? And if yes, in what direction?
So I think for me, I hold this concept as something of sentimental value. Why? Because I think it was one of the very first experiences of me experiencing the free energy phenomena. So for me, I don't think I can just detach from it and throw it in the dustbin. However, I should mention advances have been happening, and definitely I've been working on other drafts of how the systems can get to be improved. Because remember, the splitting of positives, what it seeks to do, it seeks to improve what we can term the functional abilities of the battery. But then I think one problem which we have to deal with is, can we actually get to make a battery whose lifespan is that short and get to last long? I know there are already other concepts that exist out there. You can maybe talk of the maybe beta voltaic and thermovoltaic nuclear batteries that are used. You can even talk of the neutrino voltaic batteries. There may not be technologies of these batteries that can live long, which, since they already live longer and can sort of self-rejuvenate, there already this aspect of the splitting of spores. So I think the kind of dimension which I was then using in advancing the research was, can we make a battery that is as simple as these electrochemical cells using the same ingredient, maybe the same concept of anode, cathode, and electrolyte. But in this case, they get to last long. So I think that's the kind of direction which I was taking. And I think that's how I fell in love with the research that Dr. Pollack was working on, because I think it was one person was working on, let's say a concept of how you can use the idea of exclusion zone water and the electrons that it gets to generate to effectively power, let's say, an electrochemical system. But then it's unique because in the case of the exclusion zone water that is powered by radiant energy, meaning radiant energy is always available around us, it be the heat and light, which are part of the electromagnetic spectrum. It means this battery is not dependent on electrochemical processes of oxidation, but rather is something that is also tapping into the naturally occurring electromagnetic radiation that it is also powering it. So I actually drafted a well laid out research article which seeks to explore how people can actually get to structure what we may get to term a functional exclusion zone water battery. But then, unlike other batteries, this one is more or less flexible, because one event I got to stumble into was my watching of a video of one of John Bedini's symposiums. So on these symposiums, he was actually talking about a crystal battery. So in his crystal battery, it uses 2 dissimilar metals, maybe copper and maybe magnesium. Then they are mixed in water. Then in this water, they get to put in some aluminum sulfate. And then what gets to happen is a potential difference is produced. So upon looking at it a bit more closely, I realized effectively John Bedini was just talking about the same things as Dr. Pollack was talking about. Because when you put the aluminum sulfate in water, what it does is it coagulates other impurities that are in the water, meaning you're left with pure water. And since you've got pure water and you've got 2 metals, basically those are the key ingredients for forming an exclusion zone water cell. So in essence, John Bedini was making exclusion zone water cells, but he just wasn't using the kind of terminology that Dr. Gerald H. Pollack was using, but it just does the same thing. So in that article, I was also exploring how it's very much similar and how the concept can be adopted, and how you can use a range of metals, not just the constraints that we have. Because normally when you make batteries, you have to choose between the lead metals or lithium and other kind of metals, solid metals, and more or less there is a limitation in the kind of things that you can do with it. But if you have to factor in the concept of exclusion zone water energy systems, the kind of metals that you can get to make, to utilize in making it expandable, from tin to copper to the magnesium to the zinc to the aluminum, it offers a wide range of choice. That's one key advantage, and it does so at a very, let's say, cost-effective and economic factor, which I think any kind of person from anywhere in the world that they have like sufficient economic support to do it, they can do it. And at the same time, it's something that doesn't really require, let's say, state-of-the-art expertise to make. It's something where a person has very within facilities maybe of computer-aided designing and maybe computer-aided manufacturing, they can actually get to do quite effectively. And I think that's what makes that concept quite unique. And I was involved in drafting of some of the equations of how it works, the drafting of how it can be made, a single cell prototype, and how it can be scaled. So for me, I think that's how I've been mostly spending my time in how basically we can get to make, I think, the most effective and most useful cell systems that are easy to make and at the same time functional. Because I think what makes any energy resource useful is, firstly, it has to be sustainable, right? Something that has to be affordable. It's something that has to be cost effective, something that has to be convenient, something that has to be safe, and at the same time, something that is efficient. Meaning, if you have something that observes all these 6 metrics, basically, it's a very good energy device, even in the context of the free energy devices themselves. So I think it will be more about developing something that gets to function very well and at the same time using very simple things that I think any person in any country can get their hands on. But then at the same time, I think the splitting of positives idea is useful because I think the phenomenon itself of how electrochemical systems into quantum energy, I don't think it's something that should be taken for granted because it's not something which you can just stumble upon on any random day. It's something that is a special effect. And I think that effect has a lot more uses even in the fields of biology, physics, chemistry, and even electronics as well for gadgets. I think it is quite expandable. But then I think in terms of the context of scaling up, I think it would be more convenient as well if we are to advance the kind of battery technology we should be using this effect. Because in essence, it's an effect. And an effect is better if it has a better system that it is working on. So I think that's how I've advanced with the research of this. I think I'll have to share some of the stuff with the guys who would like to take a look at it as well. And I think they can give suggestions, recommendations if they want to modify it. It's open source, so they can make their own designs based on what I've done, and get to progress the things. So I think to answer the question, that's it. That's how much I've sort of like built upon the idea of spreading of positives and how the future of it looks like.
Okay, Tapiwa, thank you very much for sharing the details. I hope this will be enough for our viewers to start at least trying to replicate your device. In case if you guys have any more questions, please feel free, as we mentioned, write your questions to Tapiwa in the comments and send us the emails so we can address Tapiwa. We've covered pretty much how we can scale the device to potentially 1-2 kilowatt to power the household appliances like a fridge or TV, etc. And wrapping up our today's discussion, we have like a few final questions. How do you see the potential applications of the technology in real life conditions or commercial projects, or maybe like if you could name a few thoughts that you have in mind how it could be used?
Well, I think one undeniable fact for sure is, energy. I think it's the cornerstone of any civilization. I think for anything as humans we do for it to work, even as for us to wake up, we need energy in our bodies to do everything that we do. So I think energy is something that is quite vital. And energy is something which, is of great essence in the essence of how it is versatile and integral. Mention telecommunication systems, transport systems. You can even mention different kinds of systems, maybe just regular energy systems for devices. It's all something that is quite possible. And I think we're entering into an era whereby there is a huge demand for energy, just by the simple fact that the population is growing, and many other industries are emerging. Mention the fields of AI and the data centers; they do require lots of energy. Mention the things to do with people involved in blockchain nodes and blockchain validation. All of those things are new industries that are emerging that still do need a lot of support from a very much stable energy foundation. I think the whole beauty of what I can term these devices, from neutron devices and everything else, they seek to give humanity, I think, an access to a resource that gets to be unlimited. Because I think as humans, we have our classical definition of the economic problem, whereby we say, we have unlimited desires, wants, needs, and at the same, we have limited resources. So I think the fact that they can exist this kind of technology simply means, for the first time, or maybe already has been, but then not yet realized, it simply means people have been asked to more or less an unlimited potential of generating an unlimited amount of energy they can use for a number of applications that they want, meaning everything gets to be amplified. The communication which you could do is unlimited. The level of security which you can get to use maybe for any other energy-dependent security mechanisms, it gets to be unlimited. The level of computing, the level of any activity that is essentially energy-dependent gets to be unlimited. The lighting, the heating, anything gets to be unlimited. And I think that's what's something that is more or less crucial in how we live, because I think we more or less creatures will function on game theory. That is, most of the times we want to strategize our best. We get to utilize resources for the best possible outcome. And I think the whole point of game theory gets to be redefined in the event whereby you've got a resource that's basically not limited by, let's say, capacity of something. A resource that is more or less expandable to do as many things as possible. If that scenario gets to be realized, it simply means you are forming a new foundation of how people get to behave and get to interact with the world around them. So I think these technologies, I see them as something that is quite, I actually would love to use the word which we can mention as canonical. They're canonical in allowing a civilization to move from one standpoint of, let's say, socioeconomic development to another. I think the thing which can effectively do that is the technology of the free energy systems. I think there are a number of reasons why people have intellectual war and stuff like that, but I think in the event that we are to fully realize it, I think it means a number of things for just who we are as a people on planet Earth, because I think anything which we deal with, it gets to boil down to energy. And I think us just making ourselves be unlimited in that context, it means we just get to be unlimited in anything else which we wish to do afterwards. So it's just unlocking, let's say, another level of functionality. That's what free energy is all about.
Sounds very fascinating to have access to this unlimited energy. And I think a lot of people actually would ask a practical question. In your opinion, what would be the approximate cost of circuit components to build a power source of 100 watt or 1 kilowatt?
So I actually think pricing it's something that is difficult to peg, because I think different countries have different prices for different things. So I wouldn't know every person's context. But I think if you were to place reasonable estimates, I think if you were to make the best case scenario will be it should cost you something less than 100. So let's just say 100. And in the worst case scenario, maybe it would be 300. I don't think it should go beyond that. Because I'm assuming, let's say a person, none of these components are in their country, they get to import them, and they're via duties. Hypothetically, I don't think they should exclude that amount. So unless it's a peg, the maximum peg, which we can put in the event that things are not working well for you, you are in the worst possible scenario. I don't think it should go beyond 250 to 300 to make your 100-watt system. Then it is now the concept like the scenario of the 1 kilowatt system. I think the definite fact for sure is, in the best scenario that I have myself against, at least in my situation. I think you can structure it with something that is just $300 itself. But as I have said, you never know someone's scenario. So I think it will be very much relative to each and every individual and their, let's say what, society or socio-economic environment.
Tapiwa, thank you so much for today's discussion. I hope our viewers had the same amount of fascination and enjoyment as we did. And to finally close our today's conversation, I keep remembering your first interview that you gave. And I would really love that all of us would have that kind of passion, like, in a good child, like passion to discover, to always look for something new, not to accept the world, the way it is in a good way, to search. This is the beauty. We are all different, and the beauty of humanity, if we all contribute, then the future is brilliant. And I can't believe that you came all the way from just watching a movie where a guy said, okay, guys, please act, do your own contribution, and you're just, okay, hey, you started to be interested deeply in the physics and the research. So my final question would be, Tapiwa, imagine that you woke up tomorrow in the world of your dream and the society of your dream. Can you discover, like, in a few words, in a few sentences, what kind of world will that be? Will we have your device in every house? Will we be, I don't know, having the cars that we do not need to charge or fuel? What kind of world that would be?
That's a very interesting question, I should say. I think the world of my dreams, to be honest, what I envision in my mind, is a world in which people get to effectively utilize something that I genuinely believe is for the best possible use to humanity itself. I once had a friend, we were talking about this, inventor syndrome, whereby you wish for the world to function as per the vision you have in your mind. Yet, the whole point of existence on Earth is about, let's say what, symbiosis, is about harmony, whereby you realize that you are not, let's say what, the most significant, but rather integral. So I think for me, the kind of world which I would really want to have is a world in which people get to genuinely engage with as many free-energy vendors out there as possible. Because I know I'm not the only person, and I know my idea is not the best and the most outstanding. However, it's useful. And I think it should serve those who see use in it. So a world in which people function in synergies whereby they have mutually beneficial values, whereby we value the same kind of, let's say what, foundational outcome as the next person. So let's say, for example, we have a common value of progress. It means the goal is more important than how you achieve the goal. That's how it gets to be like. And values are very important because values shape the way that we think as people. If you value, let's say, if one of your integral values is ingenuity and innovation, most likely a person who spends time learning different kinds of things. Why? Because you're trying to fit that value system. Our value system simply reflects who we think we are as individuals. If I think I'm a very godlike individual meant for great things, I'll develop around me a set of values that reflect that. And at the same time, since they're shaping the kind of knowledge that we have, it also means at the same time, it will shape the technologies that we have. And we see these technologies around us, right? They be good, they be bad. Each and every technology that you see around you, it's a reflection of someone's value system. That's the honest truth. Which means the problems that we see around us on Earth is not because something is wrong with the tech. Something is wrong with our values as people, what we value and what we want. And the means we did get to realize those values to feel important. And it simply means as well, if we effectively change our value system, we get to realize those goals. So in my mind, I don't think I have a world in which I picture something exactly per se, but I simply wish to wake up to a world in which people simply have a mutually beneficial and mutually inclusive value system, whereby they understand it's not about themselves, it's about everyone else. And at the same time, they understand innovation just like a light. A light, of course, is meant for you to see where you want to get, but then it's a wrong thing to then assume everyone should follow behind you as to carry the light. Sometimes people want to make their own lights as well, meaning you have to teach them how to make the light. And I think it's a very much important, I think, understanding which a person can get to realize, because people sometimes they don't venture into this free energy kind of things. Why? Because to them, in the world they live in, their values are, as long as I survive, as long as I get what I want, then that's okay. Why should I care? And I think our main goal as the creative society, I don't think it's a goal of, or it's a problem of trying to give people something that we think they should have. I think the goal is more psychological. That is, can we make people really understand that we have something that can genuinely make their lives better? Because I think change gets to happen if somebody accepts in their lives. Like, no matter how you tell someone that a free energy device is actually something useful, if their value system tells them that, well, I don't need it, they will not do it, even if they watch this video we have been doing. And I think that's where we should be moving forward, whereby we make people realize we value them, and what we are making is actually about them. It's not about us. It's not about messiahship, but it's more about progression. That's what it really is. So I think the world in which I live in is whereby if somebody loves to use neutrino voltaic cells, they should quite easily do it to power the device. If somebody wants to venture into the splitting of positive effect and it makes their power banks work quite well, then that should be it. And if somebody envisions a world in which we don't have, let's say in quotes, the extreme capitalistic version, that should be it. I have read many articles on various people. I think one interesting author is this guy called Matthew Houghton. He talks about a manly society, a world in which we were given a chance to not invent, let's say, the concept of money and something else was working. How would that society function? And I think he really gives a really interesting insight. People can look into his works. I think they'll come to realize that, yeah, the world is shaped by what we value at the end of the day. And it can be anything that we want. Even if you want to have cars, even if you want to have the cars that fly in the sky, that's us. Even if you want to have a society in which, basically everything gets to be decentralized and there isn't much governance, it gets to be possible as well. So I think that's what I envision. I don't have a specific picture for people. I think everyone has a picture of what they want to be like. I don't want to change that. But I just wish for my image in my head of progression to be similar to theirs. Because I think what matters most is progress and continuity. And I think just for a benefit to the viewers, I would like to arrange a hackathon. So in this hackathon, we'll just go through how these things work. Because some people, they have difficulties replicating this splitting of positives, explaining everything else. So I'm going to arrange a hackathon in which anyone is free to come through. We can create one giant group, or maybe a mailing list, and people just get to share their ideas, share their observations, share their relations, and get to really understand how this works. Then people share ideas of how best they're going to implement it. And I think to make this entire, let's say, hackathon process something worthwhile, we can even make our own decentralized blockchain where we store our research so that everyone else in the world gets to see it free of charge, however way they wish to say it. And if people also want to venture into the idea of the liquid crystalline cells and the experience on water batteries, make prototypes, we can also make that kind of community whereby we share notes. So it's not about me saving people, but I want to make this a community thing because we all can participate. Everyone can be a hero in their own way. I'm not the best physicist. I'm not the best designer. I'm not the best everything. So if I could have other people willing to engage, we can actually do that. And I think collectively we can get to make the kind of world that we wish to see, in which everyone's views, they're considered. And we get to see our values in something we can all benefit from as, a people. So I think, I know I didn't answer it is the way people would expect me to answer it, but I think that's my kind of answer, which I would give to people. I think it makes sense in its own way.
Thank you, Tapiwa. Yes, indeed. I think your great initiative is very useful at the moment because I think with the common aggregate of people and their minds and their ideas and the expertise in their own fields, it actually would be so beneficial for humankind to actually have those kind of development that is cross-functional and could be actually useful for humankind. And let it be that one day we will wake up with people and synergy all together together united and having common beliefs and common understanding what we as a human beings need for our life, our beautiful life, full of peace and love, and being surrounded by like-minded people. I think it's very important indeed. So thank you so much, Tapiwa. It was a great pleasure listening to you and having conversation with you. And I hope that our viewers enjoyed it as much as we with Sergey did. And again, we all encourage you to leave a comments, to like our videos, and also join in discovering newer interesting developments for the world. Thank you so much.